Welcome to The Explainer. Today, we're talking about a really cool idea in machine learning: teamwork. Yeah, you heard that right. We're going to explore why building an AI team almost always beats relying on a single, so-called lone genius.
So let's get right into it. We have this image of AI as this one brilliant singular mind, right? Like some super genius cracking the code. But the truth is, even the absolute best individual models, well, they have some pretty big fundamental flaws. And frankly, these flaws make them a lot less reliable than you'd think.
And these flaws really boil down to two classic issues. The first one is bias. Think of bias as being kind of stubborn and oversimplified. It sees a complex, wavy pattern but just draws a straight line through it. It's just missing the bigger picture. Then you've got the opposite problem: high variance. This model is way too jittery. It tries to perfectly nail every single little data point, even the random noise. It's totally overreacting. And the result? Both of these extremes lead to predictions you just can't trust. So what's the fix? Well, here's the big idea. Instead of trying to hunt down that one single perfect model, what if we just build a team? That's the core of a strategy called Ensemble Learning. It's all about bringing multiple models together to produce a final result that's way more accurate and way more stable than any one of them could ever be alone.
First up, let's look closer at why this whole lone genius idea can be so risky. This is the flaw of one.
Okay, on to our first team-building strategy. It's called bagging, and it's all about strength in numbers. So bagging is actually short for a much fancier term: bootstrap aggregating. Now, don't let that scare you. Bootstrap just means we're creating a bunch of new data sets by randomly grabbing samples from the original data. It's like giving each member of our AI team a slightly different stack of photos to look at. We're training many copies of the same model, but because each one sees a unique slice of the data, they all develop their own little perspective. You can really think of it as building a diversity team. And the way it works is actually pretty straightforward. First, you do that bootstrap sampling we just talked about. You make all those new, slightly different data sets. Step 2, you train a separate model on each one of those data sets, and here's the cool part: you can do it all at the same time, in parallel. Super efficient. And finally, step 3, you just bring all their predictions together. You aggregate them. For a lot of problems, this is just a simple vote. Majority rules. It's basically democracy for AI models. And you know what? This whole democratic approach is incredibly effective. Think about it. Each model has its own little quirks and blind spots. When you make them all vote, those individual errors tend to cancel each other out. This is exactly how bagging tackles that high variance problem. That jittery, overreacting model from before. It averages everything out and makes the final prediction much, much more stable. And if you've heard of the random forest algorithm, well, that's probably the most famous example of bagging in action. It's a real workhorse in the field. All right, let's switch gears completely. Our next strategy is called boosting, and it's a totally different philosophy. If bagging was like a democracy, you can think of boosting as building a mentorship team. It's not about voting, it's about learning from your mistakes one step at a time. So the whole idea here is adaptive learning. It happens in sequence. You start with a really simple, kind of weak model. Let's call it the rookie. You let it take a crack at the problem, and then you look very closely at where it messed up. Then you bring in the next model, but its specific job is to focus on fixing the errors that the rookie made. And this process just builds on itself, one model after another. So you start with your first model, you find its mistakes. Then, and this is the key part, you increase the importance of the data points it got wrong. You're basically telling the next model, hey, pay extra attention to these examples here. The last guy really struggled with them. So the next model in the chain has to focus on the hard stuff. You just keep repeating this, building this chain of experts where each one gets smarter by learning from the one before. So what's the big payoff? Well, boosting is amazing at reducing that other problem we talked about: bias. It gets incredibly high accuracy because it's so good at finding really complex patterns in the data. I mean, there's a reason why boosted models like XGBoost and LightGBM just dominate machine learning competitions.
Now, there is a catch. They can be a bit sensitive to noisy data, so you really have to tune them carefully.
Okay, on to our final strategy, stacking. And if bagging is our democracy and boosting is our mentorship chain, then stacking is like creating an all-star council. You get a bunch of different experts in a room, and then you hire a super manager to figure out how to best use all their talents. Yeah, stacking, or stacked generalization as it's sometimes called, is really clever. It doesn't just average the results or have the models vote. No, it adds a whole other layer of smarts, a model called a meta-learner. And that's our super manager. Its only job is to learn the strengths and weaknesses of every other model on the team, and then figure out the smartest way to combine all their different opinions. So think of it as a two-level process. On level 1, you train a bunch of different kinds of models. Maybe a neural network over here, a decision tree over there, a real mix. Now, their predictions aren't the final answer. Instead, all of their predictions get collected together to create a metadata set. Then comes level 2. Our manager model, the meta-learner, gets trained on that data set of predictions. It literally learns how to best listen to its team to make the smartest possible final decision. So there you have it, 3 really powerful playbooks for building an AI team: bagging, boosting, and stacking. So the big question is, how do you pick the right one for the job?
Well, this chart gives us a great cheat sheet. Let's break it down. Is your main problem variance? Is your model too complex and jittery? Then go with bagging. Its parallel, democratic approach will stabilize things. Is your problem bias? Is your model too simple? Then you want boosting. Its sequential, error-correcting process is perfect for that. And if you just need the absolute best performance possible and you want to combine the unique strengths of totally different models, then the hierarchical approach of stacking is the way to go.
And look, this isn't just some abstract academic idea. Ensemble Learning is running all around you, right now. It's working behind the scenes in so many things you use every day. Think about how your bank detects credit card fraud, or how doctors get help analyzing medical scans. That recommendation engine on your favorite e-commerce site, or how search engines rank results. Yep, AI teams are powering all of it. So really, the big takeaway here is pretty simple. When it comes to modern AI, teamwork is everything. The best, most powerful, most reliable solutions aren't coming from one single genius model. They're coming from well-managed, diverse teams that work together. And that kind of leaves us with a final question to think about, doesn't it? If the future of AI really is about building the right team for the job, then what huge, important problems can we now go out and solve?